welcome back to Chemically Dope by AIChE-VIT, the podcast where curiosity meets chemistry. I'm Shivaguru, joined by my co-host Ria. Today we are diving into something that was once just an imagination, but is now shaping our reality: artificial intelligence and its growing influence in the field of chemical engineering.
Artificial intelligence has become one of the most prominent topics in the today's technological landscape, with its significance growing exceptionally year after year. To help us delve deeper into this transformative field, we are honored to have us Dr. M.V. Judy, a distinguished expert and pioneer to the domain of artificial intelligence and computer science.
About Dr. Judy, ma'am, she currently serves as the head of Department of Computer Applications at Cochin University of Science and Technology, Kerala. With over 2 decades of teaching and research experience, she has made remarkable contributions to the field of machine learning, big data analytics, computational biology, and affective computing. Her research work has been widely published in reputed journals and international conferences, and she also led several funded projects supported by organizations like Department of Science and Technology, Department of Biotechnology, and state plant grants.
It's truly a pleasure to have you, ma'am, with us on this podcast. How does it feel to be a part of Chemically Dope today?
Yeah, I'm feeling honored, and we are a very privileged group where it's like we are into AI, and then we collaborate with all the other disciplines, and very happy to be part of this.
Thank you so much, ma'am. Even we are honored to have you.
Yeah,
So, shall we move on to the first question now?
yeah.
Yes, ma'am. So, to delve a bit deeper, ma'am, looking ahead, how do you think AI and machine learning are reshaping the chemical engineering and the way engineers approach the problems?
Yeah, that's a good question. When we look at how traditionally these chemical engineers they relied basically on first principles models like equations rooted in thermodynamics, kinetics, and transport phenomena. So mostly, if you look at it, the thinking was largely deterministic, and if you know the process variables, you can model and predict the outcome. It was like that. But now AI has introduced a data centric approach. A data centric mindset has come in. Engineers now blend this domain knowledge with data driven intelligence. So instead of deriving everything from the scratch, they are using these machine learning models which can learn patterns directly from the plant data or the sensor streams or molecular simulators. So if you look at an example, reactor temperature control, for example, what how the traditional approach was is the first principles approach was like they write differential equations for mass and energy balances, and then they use kinetics to model reaction rate, simulate all this using some softwares. Mostly we had this Aspen Plus or MATLAB to predict how temperature changes with feed concentration of coolant flow, and then tune the PID controller based on the model results. So this was the typical approach that was happening earlier. So everything depended on knowing how accurate kinetic constants, heat transfer coefficients, etc. were, and model was deterministic. So if you get the equations and parameters right, you can predict the behavior. But now I feel that if AI driven approach or a data centric approach has come in, and you can see that companies like BASF or Shell, engineers now use machine learning models trained on historical process data. So they have all the data, all the temperature, flows, pressures, product quality, all this historical data is there with them, and they use it as a knowledge base. They use some latest deep learning algorithms like machine learning algorithms or deep learning algorithms, specifically some LSTM networks or some random forest, which is an ML technique, to learn how the reactor behaves under real conditions, including disturbances and catalyst aging, which the equations cannot capture. So some hidden patterns can be found, or it can be mined with the help of this AI model. Also, with this AI model, will predict the optimal coolant flow or feed ratio in real time to maintain the target temperature and yield. So, what is the basic difference is you can see that the model here is not deterministic, but it is adaptive and data driven. So, continuously it can learn from planned data rather than relying on fixed equations. So, the major shift in how the technology has enhanced the chemical engineers point of way of things. So To tell you, like the results would be like 5 to 10% higher yield and 15%, almost 15% reduction in off spec batches and all that. So that is one difference which I can see. And how it has changed the way engineers actually approach problems is, so earlier it was like from intuition, it was intuition based, knowledge based. Now from intuition to it was moved on to evidence based decision making. So earlier they relied completely on intuition and experience. So if somebody wants to diagnose a reactor issue, they would do based on the observation and heuristics. But now AI tools can detect even the subtle correlations invisible to humans, for instance, predicting fouling or catalyst deactivation, etc. So it's like the data is guiding the intuition. So there is a blend in both of these things. Another major shift I can see how engineers are approaching these problems are from linear problem solving to adaptive optimization happens. So earlier it was done in fixed steps, fixed steps like you design, test, and you iterate. Now with AI and reinforcement learning, systems can continuously learn. They self-optimize, adjusting process parameters in real time. So engineers are now thinking about all this process as a dynamic system that evolve with feedback. Another shift in the thought process of chemical engineers, I feel, is that now they learn how to go, they have this interdisciplinary thinking. The chemical engineers that are graduated recently, they know how to work with an interdisciplinary thought rather than from silos. So AI, this chemical engineers will collaborate with data scientists. So this is same in the medical domain. Earlier, we know that doctors, they were into medicine completely, and you had engineering that was separate. But now, no, you have this robotic surgery. The doctors rely on the engineering for their data analytics and advanced. Similarly, here also, they know how to learn from silos to interdisciplinary approach or collaborative work. So they also learned this coding, Python, analytics, etc. And education also is a little bit, like data literacy is coming in. Not only learning thermodynamics, but also some data analytics, data literacy is necessary. Yeah. So if you look at the applications or the role of AI in in chemical engineering right now, we can even classify it into three different categories. One is matured and widely deployed are there. Already established methods are there, which you can see. Second is what is emerging, and third would be highly advanced, like we have LLMs and generative AI coming in. So, I can specifically mention few. If you're looking at as mature and widely deployed in industry type, few use cases are first, more foremost, you can see that this AI is used for predictive maintenance and anomaly detection. Predictive maintenance is very, again, I'm telling you, this is not only for chemical engineering, almost all the other branches of engineering. Even in medical field, we say that, this predictive, you can, therapy is possible. So that is it. So predictive maintenance is like, for example, machine learning models can monitor the pumps or the compressors, heat exchangers, etc., to detect failures early, so that the costly shutdowns can be avoided. So in this case, if you ask me, the AI techniques used would be like a time series anomaly detection. Continuously you take the data, and then if there is an anomaly which is coming in, it, like deep neural networks or RL can be used for predictive control. Companies are using it. BASF and Dow Chemical, they are using predictive models for equipment health, for predicting models for the health of the equipments. 20 to 30% reduction in unplanned downtime can be saved, they say. Shell uses AI driven predictive analytics on rotating equipment across refineries and chemical plants. So that's one area. Second would be process optimization and digital twin. It's very, very important use case and very well established, matured use case that is being used. I would even like to quote one real and important use case on that. So this is they create a digital twin of the entire process. A real-time AI, they also called as virtual twins. They will mirror the whole plant, for example, allowing engineers to optimize yield, energy, and safety simultaneously. So the techniques used would be, as we said, definitely to model it, we need the first principles, simulation models, plus you can use some hybrid neural network models there. Tata Chemicals, we will come back to that use case. I would like to specify that again. Tata Chemicals have used a digital twin, which is very prominently, you can avail. It's available in the public domain. You can get more details about that. And other Linde, ExxonMobil, many companies are using digital twins for this. That is one area. Third would be for quality control and process analytics. That is also an established field application of AI in chemical engineering. So here AI models will interpret the spectroscopy or chromatography data in real time to ensure product consistency. So again, Doe or SABIC, they use ML for polymer property prediction and process correction. So again, waste is less, customer satisfaction is high, and all that. These are all established one, or maturity level is high in the case of applications. If you are talking about emerging and expanding, like in the year 2023 to 25, which is one basic AI modeling is something called as hybrid modeling, which blends the first principles with ML to capture both physical realism and data driven adaptability. So there is a specific neural network model which is called as PINs, physics informed neural networks, or the other gray box ML models also can be used. You can see Siemens Processing Systems Engineering. They integrate this hybrid AI into GPROMs for chemical process design. Even Shell, they have a project called as Oren. They apply this hybrid AI to simulate multi-phase flows. So more robust predictions can come in and all that. So to add little more onto this, please refer to the Tata consultancy. They have come out with this digital twin. I want to specify this as an example, which is in India. TCL has implemented an AI-driven digital twin system for key assets in one of their plants. I think the plant is in Mitapur site. They have joined hands with their own company like Tata Consultancy Services. I think they have around 32,000 sensors collecting time series data from various sources. And this digital twin model generated, real time set points and operator recommendations to adjust the parameters. So they say around 6 lakh of US dollar savings were there. That was cited in one of their public report, which that's due to increased yield and this reduced variability. They could save, or the savings was around 6 lakh US dollars. So you can see that in this case, because of this digital twin, efficiency has increased. Okay, plant process variation was reduced, output was boosted, output yield was boosted. And if you see the safety also, because of virtue of this continuous monitoring, earlier detection of offset in process parameters or better asset health monitoring was done. And innovation is must be very most important is it is not just a control loop tweak whatever we had earlier. Here it has integrated the large sensor network. It used the historical real time data and the AI models and the digital sense simulation of what is process behavior. So it's like a complete shift from traditional first principles only towards hybrid models. So these are the things. These are many use cases or applications where you can see AI has come into chemical engineering process. Coming to the next part of your question, I think you asked how AI for sustainability and pollution control, what is available, what are the different things that are available
Yes,
for
ma'am.
sustainability and pollution control. I can mention few. Say there is AI models can analyze real time emissions. It's like you have emission monitoring and control can be done using AI models. So they analyze this real-time emissions data to adjust process parameters and keep the pollutants below the threshold. So it keeps continuously monitoring, and if there is an real-time emission which is above the threshold, it can actually bring it down, or it can the earlier information will be made. So you can check into the IBM's Green Horizon. So that project they use AI to predict and minimize factory emissions. Then coming to sustainability, waste minimization is another. AI can optimize raw material use, and it can recycles byproducts to process redesign. That is very important area because Tata Chemicals are they are doing this. With the help of their digital twins, they improve resource utilization. So they go for recycling byproducts through redesign. Third one, maybe I can say carbon capture and conversion (CCU), which is very as a AI helps in designing this catalyst and materials for CO2 capture and conversion into useful chemicals. You can also please check into the DeepMind by Google and Total Energies. They are using this AI for catalyst discovery. That's another I mentioned earlier also. It's a very important prominent field in AI and chemical engineering. The other one, maybe one more I can mention is circular economy optimization also. So we have algorithms in AI which can map your waste streams and identifies reuse opportunities across industry. So again, you can see all these giants have their own projects, and this BASF, they have a chem cycling project. This uses AI to optimize plastic waste recycling. So I think I've answered few.
Yes, ma'am. So we'll move on. Thank you for the deep insights on regarding the sustainability thing. As a chemical engineer, we focus on sustainability to develop processes to develop sustainable process also. So yeah, and
That's good. That's more important. We come to you for all this.
yes,
Okay. So, looking ahead, how do you see AI affecting job opportunities for chemical engineers? Will it open new paths or could it pose challenge for their careers?
Yeah. So is it going to help you or hurt you? That's the question. Definitely, all these technologies are bringing in opportunities. That's for sure. Okay, so everybody has this question. Even the students or the people from computer science domain have this problem. Whether our what are we to do? Is it going to bring us some risk? Every domain, everybody has this problem. Even HR, if you look at management, even in HR, because of lot of this automation which is happening, they also have a thought that whether AI is going to bring that. Then there is a shift in job opportunities, but definitely AI. As we said, we cannot just talk as if nothing is going to happen. It's not like that, but definitely there is going to be a different role change. For example, repetitive tasks like your in like cleaning, basic control tuning, or routine experiments, all this maybe AI will replace, but at the same time it will create demand for engineers who can combine process knowledge with data skills, like hybrid modeling, digital twin engineers, where they will always want a computational chemistry people kind of, where you have a good domain knowledge in chemistry, but you also know the data analytics part or the AI part a little bit. Like they need the process data scientists and so on. So Mm, generative AI and automation may impact a little bit for the routine analytic and drafting tasks, but definitely an upskilling is also essential. Okay, I've been just looking into thinking what are the different job opportunities for chemical engineers. So there are various roles that you can check into, like if you have a process data scientist is a prominent job role that is being that companies seek nowadays, or ML engineers in chemical plants. They can build soft sensors, anomaly detection, digital twins, and so on. Predictive maintenance engineer or reliability data engineer is necessary. Then control AI engineer, where real-time control integration and hybrid models are there. Materials researcher or catalyst AI researcher, a computational chemist is important. Process automation engineer is important. Then, as the traditional process engineer, plant engineer are still needed, but role shifts are there towards supervising AI systems. So it's like there are many companies, typical companies actively hiring. BASF, Dow, Shell. Please log in and see even Tata Chemicals. They still hire chemical engineering students. It's basically we can see that universities are also designing their curriculum. in such a way that even for a medical student they need to know engineering principles up to some extent. At least they should know how to interpret the results, how to use this ML models, how to look in, how to integrate AI into their systems. So that is also necessary, and the curriculum is also being designed in such a way that so you will know how to handle this AI integration. So there are this technology and industrial automation vendors like Siemens, Honeywell, ABP. They also ask for chemical engineers because they need control AI solutions for their plants. And you can see this data and platform companies, when they develop any stack, chemistry related application technology stacks, they need chemical engineers for them. And a pretty good LP also, I was just checking, are there, like the highest could be like if you go for an R&D AI for materials or catalyst engineer, chemical and engineering, 30 to 50 LPA in India also people are offering. I don't know, for you it is a how do you consider 30 to 50 LPA? But I was just going through to check how the job opportunities are there for chemical engineers right now.
Yes, ma'am. Thank you for sharing a big issue where every engineer face. And so to wrap up, ma'am, especially for the students and young engineers tuning in, what's the one key piece of advice you would give for navigating an AI-driven future?
AI driven future is the I would tell my students, you have to keep running to stay where you are. So we have to keep updating ourselves, not only a student, even the professor. In fact, everybody, even the legends, now LLM has come in, generative AI has come in. So even the basic, the legacy systems that were there, even the softwares that were there, even if you look at a PowerPoint or an Excel, they also try to plug in all this, LLM concept, GPT concepts, because they are updating themselves every now and then. We know that Google has come up with it. We had the Google already, we search engine that was there, but now ChatGPT has come in. So Google also has come up with generative AI concepts, and they're plugged in into their search engine. So whoever it is, technology keeps changing. Okay, so we have to keep updating ourselves. You should have an open mindset to update and understand what happens, and we should keep learning every time. That's what I said. If we have to maintain the status quo, we have to maintain us. We have to keep running. I mean, we have to keep running to stay where we are. That's what I feel. Every time we have to keep learning, keep studying, and it is not tough. We have seen lot of revolutions, so it's not something very challenging. Generative AI is another revolution that has come in. So there's a lot of talk in industry that because of generative AI, a lot of jobs is there, and losses are there. That is there, but we have to update ourselves, because initially when computation came in, in the banking sector, earlier it was digitalization. There was a problem. Then they said internet banking, there'll be a problem. But we have to use all that. We cannot just stay back and say, actually we humans have the capacity to adapt ourselves. So whichever technology comes in, we will learn and we will excel ourselves. So only thing is we should have the attitude for doing it. This is just out of my mind, whatever is coming in, I'm just telling you. That's how it is. It's not for the students, it's even for the professors, and it's for the top tier level one companies, the giants, even in the IT industry. Everybody, they keep learning and adapt themselves to the latest technology. That's a necessity, need of the hour.
Thank you so much, ma'am, for all the valuable insights that you have given. So, as we have come to an end of all the questions, so with that, we have explored the various aspects of artificial intelligence and its future in the field of chemical engineering, along with some interesting facts and reality. On behalf of AIChE-VIT, we sincerely thank you, our guest, for sharing these valuable insights with us today.
So, and to all our listeners, if you enjoyed this episode, don't forget to like, share, and subscribe Chemically Dope for more engaging conversations and engaging topics.